Plants hide their secrets outside visible domain. Hi, I'm Egor Prikaziuk, and today I'm going to tell you about sensors in remote sensing, the topic of Senseco Working Group 3. Let's get started. Spectral spectrum is infinite electromagnetic radiation, but it enters Earth in the wavelengths of sun and leaves Earth in thermal domain. And we can observe both signals. First, optical domain, where solar radiation enters the Earth. Water, soil, and vegetation have different spectral signatures. That's why we can easily differentiate them. There are different techniques: single band, multi-band, red, green, blue, multispectral, and finally hyperspectral. We are going to cover LIDAR, RGB, multispectral, and hyperspectral remote sensing. LIDAR or laser scanning in fact uses one wavelength and near infrared. It can be terrestrial laser scanning that produces point cloud, or it can be also airborne laser scanning that produces a topographic map of the area. It can be used further in, for example, 3D models discussed in the previous videos. RGB uses already three bands, red, green, and blue, and can also be used to create a point cloud with the structure from motion or photogrammetry technique. Further usages are described by Sharmani and by Milica and Senseco webinars. Multispectral remote sensing is based on the fact that we can, of course, differentiate the greenness of the leaf, but in near infrared, it's much nicer. That's why extra band, near infrared band, was added. And this sensor synergy is has long ago been introduced into remote sensing. You can see that in the photograph, the vegetation is red and it's perfectly distinguishable from road path and water. You can also see how different resolution affects. You can follow talks of Nuno and Radley and the usage of multispectral remote sensing. Usually, it's used as a vegetation index. Finally, hyperspectral is when full spectrum is recorded. There are chlorophyll absorption bands, water absorption bands, and all this information can be gathered and processed in, for example, Nmap toolbox of the incoming hyperspectral satellite mission of German Space Agency. There is a tutorial on Senseco webpage. Also, RTMO toolbox provides retrieval routines. Recently, the most attention got the chlorophyll fluorescence, this tiny peak on the reflectance curve that is related to photosynthesis. Solar-induced fluorescence is the scope of a FLEX mission of European Space Agency and is discussed profoundly by Na and by Subhanchik. Thermal domain is the energy that leaves the Earth because Earth has some temperature. Thermal infrared domain reflects how leaves cool themselves, similar as when we are sweating, leaves release water. It's also possible to detect diseases nicer with thermal photography. For example, after 2 days, invisible we see nothing, but in thermal we see already spots of infection, and only in 5 days can we see invisible. But transpiration monitoring is discussed by Veronica and by Emre. Finally, the last domain is microwave domain that is located here. Earth emits little energy in this domain. That's why it's more often used like an active technique when the pulses are sent by satellite himself in X, C, L, and P bands. The difference between bands is the depth of penetration in vegetation. For example, L band is very nice to depict deforestation, and C band is nicer to see paddy fields. Also, vegetation optical depths from radar is related to biomass and seasonality, discussed in the previous video of Working Group 2. That was it. 3 domains: optical, thermal, microwave. The synergies are governed by Working Group 3 and Miriam, Uwe, and Marlena in the collection of multi-sensor datasets, stress detection at phenological stages, and guidelines for retrieval. These were sensors in remote sensing. Stay tuned.